All right, we're live. Okay, so starting with lesson 6, does anyone have any questions or any concerns about that one?
Well, I just
I did okay with the homework quiz on that one.
I just have a question about last week, and just to make sure that we sent in the collaboration information, because mine didn't show up on my, so week 3, it doesn't have the check mark next to the group collaboration.
That's because we didn't need to send it in. That's the only, or not Seth, sorry, you're Seth. Thomas is the only one that sends it in, so he's the only one that's going to have a check mark on it.
Oh, I had a check mark though on week 2.
You must have clicked a thread or something.
Oh, okay. Actually, no, I didn't.
Yeah.
I thought I did.
Yeah, he said it's okay if we want to just post a remark up there just to clear the question.
Okay.
Yeah. If you see my comment in there, it's done. So don't worry about it.
So I must be just really stupid because I didn't understand. I can never figure out how they're getting, and I just didn't understand it at all.
What did you not understand?
The lesson 6 and 7, for some reason, it's just not clicking in my head, so I don't understand how they're getting those numbers.
So it's pretty similar to what we did for 4 and 5. It's just adding another variable into the mix to come out with what we did for 4 and 5.
To put it simply, it's kind of like we're not finding the mean anymore, or we're not finding the standard deviation anymore. We're finding the mean of the means. That makes sense.
Yeah.
So we're finding the standard deviation of the means of multiple samples, not just one sample.
Yeah. So we're taking group samples, multiple group samples. So 100 people in this group, 100 people in this group, 100 people in this group. We take the mean from each of those and then get the mean from all of those samples.
But the mean is always going to be the same as long as the distribution is normal, or like, because I was just confused. For the mean of the samples, and I'm not like so it's just the same mean as you always get.
Well, did you watch the videos? Because the videos.
Yeah, I'm watching the videos, and that's kind of what it's saying, but I don't know. I must. But
the reading's complicated, and he even said in his posts is like the reading is really like in the weekly posts. He said the reading is not an easy read, and it takes a while to get through it to try to understand it all. But even after I read it a couple times, I still was like, "What?" But the videos complement it very well, so it's pretty much means the same. Find the standard deviation. There's a little bit of there's just an extra formula to find the standard deviation of sample means. And
yeah. Okay. So sorry, you guys are gonna hate me, but can we go? So like for 8, number D, would I take 113 divided by the square root of 10? Is that what I would do in absolute answer? Or
what are you looking at?
Yes.
8 on the
preparation.
Yeah.
On lesson 6 preparation.
Yeah.
Let me check. Let me look at it real quick.
I don't know, because I just must be stupid. Okay. Yeah, I got okay. That makes sense. Okay, we're good. Thanks.
You're welcome.
I don't know. Just the way they wrote out the formula, I was like, that doesn't make any sense. Where are they getting these numbers? What's going with what? I don't know.
Yeah.
I think the hardest part is knowing what the symbols are.
Yeah. That's one thing I want to ask you guys. because I always thought X bar was the mean, but now it's that little U thing that's the mean. But that's confusing to me. Which
The
I
U
want.
thing has always been the mean. The X bar, isn't that the number that there's?
So the X
Guys,
is
please.
considered the mean of that sample. This is what I'm like. This is how I'm getting it and
Yeah.
understanding it. The X is the mean of that sample, but then the U
No,
is the mean of the mean.
the
Yeah, that's what I-
X bar is the simple mean. X bar equals simple mean. And the
Yeah.
mu
That's
is
my
the,
understanding.
and the mu is the
Population mean.
population mean.
Okay, so then in the formula, so the formula for like in the preparation number 2,
Keep the noise
E
down.
equals the sample mean minus the regular mean times by the divided by the square root of the number that we're
Sample
the sample. Is that right?
of the sample, yeah. The SRS.
Yeah.
That's just confusing.
Yeah, you just gotta just, as long as it's just a formula, you gotta trust it. I mean, a lot of it, try to make sense of it. It's a little confusing, but just, we can
It's
just
just a
trust,
lot of letters.
yeah, just trust the formula.
I didn't like the O with the line above it, the sigma, because that was
Standard
confusing
deviation.
where, yeah,
That's the
Exactly.
standard deviation, right?
I know it's
Yeah.
the standard deviation, but it was also called sigma, and I don't know. I was looking for some equation with sigma, and then later on in the reading,
I don't like the symbols, they annoy me, but alrighty. Did anyone else have any other questions, or are you guys ready to go for the test?
I'm good with the quiz for lesson 6 and 7. So,
Me as well. So let's go ahead and, if there's nobody opposing, let's go ahead and start the quiz for lesson 6.
Lesson 6.
and did you guys make an Excel sheet to do the z and the standard deviation and all those other equations, or are you just doing it by hand?
I'm doing it by hand.
Are you Excel? I didn't even know. Is there a way to put that in there?
Yeah, you can do it with Excel.
You
Well,
can
you can
do it.
create-
There is a formula.
You can create your own formula on Excel, but I just do it by hand. It's not a big formula.
Yeah. Oh,
Yeah.
That's cool to know that.
Okay. Group quiz. What's group meeting quiz? There it is. All right, I'm starting it.
Me too.
Oh man, hold on. I need to go grab a calculator. I'll be right back.
I had a calculator. I don't know what I did with mine.
I Google calculator. My friend took my calculator.
One point in my life.
I had to steal my wife's phone because mine just died. Man, I can't remember her password.
Well, if you have a big enough screen, you can put the calculator. You just type in calculator on Google and just use that one. That one's good enough.
Okay, let me bring it up.
So 1 and 2, I guess we can just answer those by ourselves,
Yeah,
and then just start on 3.
you bet.
Okay.
How many questions do we have? 12.
When you take a sample size of n equals, what is the sample, or what is the shape of the distribution of means histogram when the parent population is right as skewed?
Okay, it is right. It's skewed right.
So it's always just the same whatever the parent population is, right?
No, because if n was 30, it would be normal.
Yeah, if it was a bigger yeah. The larger the size, the more normal.
The closer it gets to the center.
Oh, that's right. Okay.
Yeah.
Okay.
So question 3 skewed right.
Agreed.
Wait, now I'm confused.
What's that?
Because this one, you said the closer that I get, if that's 100, wouldn't that be normal then? Because
No,
it's
Yes.
Yeah, now it's normal. Yeah.
okay. So when you said I skewed it threw me off.
So question 4 normal, right?
Correct.
Right.
When you are taking sample size N5, what is the shape of distribution of means when the parent population is normally distributed? Normal.
Normal.
Right? 'Cause it's normal.
Yeah, whenever it's normal, the results are always normal.
Those just try to trick you. All right, what are you when you're taking a sample size of N100, what is the shape of the distribution of means, histogram, of the parent population is normal again, correct?
Yep.
Yeah.
When would the distribution of means be normally distributed?
Okay, data showing population is normally distributed in samples. Okay, the first one
Whoa.
Uh-huh.
is drawn from a large population. The
It's
second
true
one,
for number. So data are drawn from a population that is normally distributed and the sample size is small. Does everybody have that one
So
as number 1?
No, it's got to be large.
It's everyone except for when it says the data is drawn from the population that is right skewed inside sample is small. So everything but that one.
oh,
Right?
we have it in different order. That one's the third one for me.
That one's my
Same.
third one too.
Okay, so let's just go through it real quick. So the only one that should not be checked is data are drawn from a population that is right skewed and the sample size is small.
Correct.
Okay.
Does anybody have questions about that?
Nope.
No, but it should be data is drawn, not data are drawn. Just a little typo. No big deal.
Oh,
He's a math teacher, not a grammar teacher. It's okay.
well, and he's probably not the one that wrote the.
No, he definitely, I guarantee he isn't. I was just messing. If you are, no big deal. I was just joking. All right, which of the following gives the best explanation of the central limit theorem? Okay, how about we all read it real quick and see if we come out with the same answer?
The third one down. If the sample
Which
size
what?
is large, if the sample size is large, the simple mean of the simple mean will be close to the population mean.
No, hold on. No, that one, that's the law of large numbers.
Yeah. Because I thought it was parent population from whichever the data are drawn is normally distributed, then the sample mean will follow a normal distribution.
That's not it either. So what the answer is,
If the
sample size is large, the shape of the distribution of sample means will be approximately normal.
Approximately normal.
Oh,
That's the way.
okay. So the other ones are the large number, and the one that uses approximately is the one with. Okay, that makes
because
you're right.
With the central time theorem, it's talking about as you gather more data, it's going to get closer and closer to normal. So that's the whole theorem.
I forgot that one uses like approximately, and that's how I define it. Yeah.
Yeah.
It's verbiage.
Okay. Alrighty. Let x of random variables have a population mean of 10, standard deviation of 6. Suppose size n is drawn from this population. What is the mean of distribution? Okay. So everyone, I say, let's just do it on our own, see what we come out with.
Right.
Everybody ready?
No.
Hang on.
I'm like. So we're trying to get the distribution of the sample means. Standard deviation. Okay.
This one should be. This one should require no math.
Oh, true.
It's 10.
No,
It's 10.
Oh.
10.
Oh, times 1. Okay.
It's given. It's always, and
Yeah.
it tricked me in the past before.
Yeah, this
But
one's
if
tricky.
you read it, yeah, it's given. It's always given. So it's a 10.
Yeah, it's the mean of the distribution of sample means equals the mean of the population mean. So answer is 10. And now it's asking what is the standard deviation of the distribution of sample means? Okay. So now
This requires a cut.
this one requires, you shouldn't need it either because
It's
the number is,
1.
you know, it's a square rootable number, whatever. I can't think of the verbiage on that one, but the answer should, on this one, the answer should be 1.
That's what I got.
Okay, good.
Okay, so we're on number 11, right?
Yeah.
So everybody got 1?
Yep.
Yeah.
Yep.
Regardless of the distribution of the population, if the sample size is large and greater than 30, what would the shape distribution of the sample mean? Normal, right?
It'll be normal. It's because it's greater than 30.
Yeah. What theorem would justify the response for the last question?
Central limit
Central.
here.
The law of numbers.
No, central limit theorem.
Central limit.
Okay. I need to read those again then, because I'm confused.
Just so go to the bottom of the lesson in the textbook and go over the key points. That really helped me, just going over those key points, and I wrote them down, so it converted it to memory a little bit better.
It's good.
Yeah, I read.
And that's what I did as well. Is I read what the key takeaway or like the summary was, and then you start at the top and then go through it.
Yeah.
Mhm.
Alrighty, I'm gonna submit. You guys ready?
Yep.
Can I go back to number 10 right quick? Everybody said it
crap.
was 1. The answer was 1.
Yeah. Number 10 is 1.
Yeah. We got 100. Woo!
Yay. Okay. Well, that one was nice and easy. My heavens, glad that one was over.
Is that how easy the homework quiz is?
Yeah, I feel like the homework quiz was a little bit harder than that. I can't remember.
Yeah, it was.
Well,
Well, I think the homework is supposed to be harder than the group quiz
Yeah,
because
don't tell me that.
I was just teasing.
we do this one. We're supposed to do this one first. But okay, moving on to group group meeting quiz number 7. Did anyone have any questions that they wanted to go over on 7?
Nope. I think I'm good.
So just before we start, how about everybody bring up the applet normal distribution thingy, if you don't have it up already.
And I
Yeah, I
put a
got mine
comment.
The sample distribution or the
You know that little the applet, the thing with like
Curved
the,
applet.
yeah, the normal distribution applet.
probability.
the
Normal
one with
probability.
the score?
Yeah, where you fill in the blue.
The Z scores on the
Yeah,
bottom.
It's
There
in
you
the
go.
chat.
That's a
Yeah,
good
I
description.
put it in the chat.
My description of it is the blue thingy that you fill in. Okay. Group meeting quiz.
Right.
I spent a long time on this one because I just
I had
really
to
wanted to
read
make sure
this
I
several
understood it.
times before it started making sense.
Yeah, well, I usually don't gather it 100% after the reading, but then once I watch the videos, like I watch all the videos and I go through the videos very slow because I follow along with them. I do the problems and that
Right.
helps a lot. It helps a lot.
I got
So-
a full-time job. I'm sorry.
Oh, me too. Me too. It's just,
Don't even worry about it.
yeah.
I'm right there
I'm
with
so far
you.
behind. I'm behind this week a little bit.
Oh, it's just my Sundays and Saturdays are completely taken up by online classes, and my Monday nights. So I have no social life. Luckily, I'm married, so I don't need one. Okay, I'm ready to start. Are you guys ready?
Yeah, I've already opened it.
Mhm.
Okay.
Oh, okay. Seth's moving along. He's got stuff to do tonight, guys. We gotta hurry. All right.
More homework.
I'm just kidding. All right. All right, 15 questions. Okay, answer the first 2 on your own.
Okay. Done.
Okay. Question 3. Oh. Computer. All right, use the normal probability applet to find the combined area of the standard deviation of a normal curve with a z-score of 1.35 and a left of negative 0.135 or negative 1.35.
8. You've got the 8.
Let me see. 1.358.
8255.
I got 0.683.
Did the middle part, right?
Hold on 1 second.
Yeah.
Put it 358. Yep. Okay.
Yeah, you got.
So
What
what
is
is
it?
centipede?
Hey, can I call you back in a moment? Yeah. Mm-hmm. Okay, that is your bye.
With the fun combined area of standard combined area of the standard deviation.
Wait, so for 3, everybody got 0.683, correct?
No, we haven't done it yet.
Now you're talking about just the centerpiece.
I don't know if I don't think we're asking the centerpiece because it's saying what is
It's
to the it's what's to the right of 1.358 and what's to the left of negative point. So it's I think it's asking everything
So
but the
it's
center.
point 912 or point
So
one point 913.
174. I got 0.175.
Oh, what are you guys highlighting? Are you highlighting the middle?
I'm highlighting the
The
outside.
middle and the right.
I think we only highlight the outside.
But it says it's to the right of negative plus the
No.
positive. No?
Yeah, it says it's to the right of the positive number and to the left of the
Of
negative.
the negative. Yeah.
Okay, okay.
So it's
Yes.
0.175, right?
Yeah, 0.175 is what I have.
I should have read that better. My bad.
0.175. So that's the two wings.
Yeah, that's what it looks like. That one is worded. That one's trying to stump you. That one's tricky. Okay. Which of the following number have a smaller standard deviation if 9 observations were drawn from the population?
The distribution of the individual observation X, the distribution of the mean sample X. This cannot be determined from the information given.
No, so one of them's always smaller. I remember that.
Isn't it the anything?
I think it's distribution of sample means X.
Simple means would be the X bar.
Yeah, so I'm pretty sure it's X bar. Let me review notes real quick. So I remember one is smaller than the other all the time.
Let's see.
Is the X bar. If you look on the preparation question number 3E.
Yeah, I'm pretty sure it's X bar. I'm just gonna pull something up real quick. I have some notes on my computer, and I just wanted to check my notes because I remember writing this down after the quiz, after the homework. Sorry, just give me a minute, guys. Yeah, I'm pretty sure it's X bar. I can't find where I found that out, but I remember that.
So sample means?
Yeah, sample means would be X bar. Because that one's always tends to be smaller. And I remember thinking, yeah.
Right. Which of the following results implies that the spread in X bar decreases as the same size increases?
That is log
The
plus.
large numbers.
Yeah.
Large numbers.
Mm-hmm. I agree. Everyone good on that one?
Yeah.
Okay. There it is. Okay. Scores on a quantitative portion of the GRE are approximately normally distributed with a population mean of 150.8 with a standard deviation of 8.8. Okay. Diane earned a score of 160. What is the z-score corresponding with Diane's score? Okay. Find the z-score. So looking for the z-score. Everyone do it on your own, and then we'll discuss our answers after.
Okay.
Wait. Need scrap paper. Where did I? There we go. Okay.
Really quick, as people are doing this, the sample size you guys got is it 1?
What?
No, Seth, this is kind of a review of the last chapter because we're not doing quantitative, or we're not doing sample means. We're just finding the z-score of an individual thing. What it looks like.
Oh man.
So
I come up with 1.04.
It's 1.045.
Right,
Is
that's
that
what
what
I
you
come
got?
up with too.
Okay, so
Yeah.
So Seth, do you understand? Because on this one, we're going back to the original formula where it's just x minus the mean over standard deviation. We're not square rooting anything because this one doesn't require it. Because this one is just a single. This is just a single occurrence. We're not looking at a sample means. We're looking at just a single whatever. Does that make sense?
Yeah, so what did
Yeah.
you guys get?
They don't ask for SRS. They don't give you sample population to use from.
So what did you guys get again?
So you're taking 160.
1.045.
Yeah.
1.045.
Okay. Hold on.
Right, what is the probability that a randomly selected student would score above 160? See, and Seth, here's what you got to look for, and it is for everybody because I always get tricked on this. But what you got to look for is usually it says on the sample, what is the probability that a sample would be selected? But this one's just asking what is a randomly selected student. So that's just an individual student. It's not. We're just trying to find a single item, not a full, not an entire mean. So.
Right. So then we're gonna put what we got into the blue thing, and then it's everything above that, right?
Correct.
Okay. I got 0.296.
That's not what I got. I got 0.148.
At 1.480.
Yeah.
Because you got to go to the positive side only, the right side wing.
I did.
Make sure.
And you
that
got what?
the
And you
z-score-
did you?
Oh, yeah, I see it. Never mind. I forgot to unhighlight the other one.
Okay.
I didn't see her.
You guys got 0.148.
Yeah.
I do.
Well, 0.14. Yeah. 0.148.
We need to do the 0 in front of it.
No.
Okay.
No, that's the point. Make sure to put a point.
I did.
Okay. Question 8. A random sample of 5 students was selected to take the GREs. Their scores are as follows. What is their z-score corresponding to the sample mean for these students' scores? Okay, what is the z-score corresponding to the sample mean scores? Okay, so first we got to find the mean of those.
The mean, right. Take the sum of all that and divide it by 5.
Correct. Everyone do that. Let's make sure we all got the same thing.
Okay.
I got 160.
160.
160. Okay, me too.
So this is X, the hyphen above it, right?
This is the
This is
X
mu.
bar, yeah.
Yeah. Okay.
The mu.
So now we're trying to find the X bar minus the mean times the standard deviation divided by whatever. Is that what we're going for?
Hold on one sec. So what is the z-score corresponding to the sample mean of these scores?
So what's the value?
Hold on. So I think we actually got to plug because we got to find out what the standard deviation is of these numbers.
So is every
Wouldn't it
sample minus.
So we got to go back to the spreadsheet. This is taking us back a little bit because to find out the z-score. Because for the z-score, we need.
So you got to take each sample minus the mean. Then you got to do that to the square root and divide it by the sample to get the z-score corresponding to the sample mean.
Hold on.
we're not doing the no, isn't it the X bar minus the mean, the standard deviation? Because we already have a standard deviation. It's 8.8, right? Why would that change?
Where do you get 8.8?
It above it says use right above 6. It says use this information to answer the next 4 questions.
Wait, right above which number?
6. Question number 6.
Oh man, I was thinking this was a new question. Okay, that's my bad. I'm sorry, guys.
So it's just the X bar minus the mean times the standard deviation over.
Yeah. So here, let me regroup myself because I thought this was a completely new set of questions. So we're going to take the GRE score. The mean of that is 160. Okay. Find the z-score corresponding to the sample mean. Okay. So we got. So the regular mean is.
Oh.
So we got 160. So we take 160 minus
50.8.
0.8. We put that over.
No,
8.
you gotta times it by 8.8 first, don't you?
No.
What?
No, you put 8. 4. We're just finding the z-score.
Right.
So it will be 9.2 divided by 8.8.
So 8x. So you're thinking we're solving for x. We're not solving for x. We know x. X is 160.
No, I know that. But the formula for finding like for example in the preparation question for lesson 7 number 2, I asked what the formula is, and the formula is z equals X bar minus the mean times the
And that's what we're doing. So x bar.
the standard deviation.
X bar is. X bar is 160
Yeah, I know.
minus 150.8, and then you put that over 8.8 divided by 5, the square root of 5.
But in the formula, that's what I'm.
Because of this.
You guys know where I got
samples.
Formula. What I'm saying is, if you look in the formula in lesson 7, the formula is x equals x bar, which is 160, subtract the mean times by the deviation over n.
No. Well, I don't know what that one is. That must be like maybe if you're solving for something else, because this is the formula for finding the z.
Right, and she's right. Now, I agree with Michaela. That is the preparation question number 2 does say that
mean standard deviation. Z equals value mean standard deviation equals x over in the book.
I know, but this is.
So let's everybody come up with their answer, and then we'll talk about it after that.
Okay. Yeah, I think that's a good idea.
Okay.
So let me know. I got my answer.
Okay. Doesn't have square root on it. Well, no, it does.
Oh, I just use Google Calculator. It has that.
Yeah, hold on. I'll be right back. I need to grab my other calculator.
So right now I'm at 2.338.
That's what I have. 2.3377074, whatever.
Ah, my calculator is like glitching out.
Yeah, sorry. Just give me a minute. I gotta charge it up. It's coming up right now, but I'll do everything else. So.
What's going on? Oh my gosh. I need to get my calculator. I think it's upstairs. I don't know what I'm doing wrong.
Okay, Seth, are you there? I was not. Ed, did you get an answer?
Yeah, I got 2.338.
Me too. I got 2.337, but man,
Okay, I'm doing something wrong. I don't know what I'm doing wrong.
Hey, Seth, what did you get?
I got 2.3377074.3. keeps going.
Okay, so 2.3. You guys got 2.338.
I did not. Can you guys walk me through the question then? Because I don't know how I'm doing wrong.
So yeah, so you just got to use the formula. It's z-score minus, or z-score equals 60 minus 150.8 divided by the standard deviation of 8.8 divided by the square root of n, which was 5.
Okay, but I have a different equation here. I don't. Then where are you guys finding that equation? Because I can't. It's
From
not.
the videos. From the videos. That's
But
where I
it's
got it.
different. So it's different than the one that's in the. Oh, I see. It's over there. No, that one's still it.
So the equation is z equals value minus mean over standard deviation. So value that we got was the mean of the
No,
sample.
I know where you
which
guys
was
are getting the
160.
numbers. I just don't understand where you guys are getting the equation. Does that make sense?
It's from the. I got mine from the video. That's where I got it.
That's where I
I'll
got
have to look it in there. It's not in the book. Okay.
Yeah.
Okay.
I'm gonna check the book real quick, because I'm pretty sure. I mean, it's ought to be there if they were using it in the video.
Because the
Might
one
be
that
in
I have
section.
is x bar minus the mean times the standard deviation over n. Over the square root of n.
Say that one more time. Sorry.
Minus the mean times the standard deviation divided by n, the square root of n.
Yeah, no, that's not what I got.
It's not times, it's divided by.
Yeah. See, I'm looking at it right. See, it is so it is there.
Share
So
your screen.
so go to probability. It's right on it's right in the textbook on probability. It's on section 3. It says value minus mean divided by standard deviation, and then it says x bar minus mu equals. Do you not see what I'm looking at? Because I see it right in the textbook.
I don't know. I printed out the textbook so I could read it when I was at work.
So if you go to lesson, it's just like, you know how it goes lesson outcomes number 1, and then a review sampling distributions number 2. It's right under.
Mhm.
It's number 3. It says probabilities involving a mean. It's right there.
Okay.
Right. So
What did we get?
So you guys
2.338.
2.338 was the answer.
2.338. Okay. Is question 9 a different?
You used that answer to do what we did. We used the normal probability applet for this one.
Yeah. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by students in the previous problem? Greater. So we go 2 point. So we just put in 2. We punch that in on the z-score. What was it? 2.338. And we do greater.
So it would be 0.0097.
So 0.010.
I got 0.00. I got 0.001.
Oh yeah, 4 decimals. Yeah, that's what we want.
Yeah.
3. It's just 3 decimals. So 0.001, right? Or are we?
4 decimals. Okay, it says round your answer to 4 decimal places.
Okay, so this one 0.0097.
Mm-hmm.
Everyone get 0.0097?
Yep.
Yep.
Yeah.
Okay, suppose the mean GPA of BYU is 3.5. So mean is 3.5, standard deviation of 0.7. And it's left skewed. A random sample of 81 students. Okay. Question 10 is going to be approximately normal because there's a large sample. Everyone agree?
Yes.
Okay, what is the mean of the distribution of the sample means? Probability of sample size is drawn from the population. It's 3.5, right?
3.5, yeah. Or approximately. I don't know if you can type that in.
Yeah. So what is the mean of distribution of sample? So the mean of the distribution of sample means equals the population mean. So that is correct. So
Yeah.
number 11 is 3.5. What is the standard deviation of sample means for all possible samples? So this one we're just finding the standard deviation. So we take 0.7 divided by square root of 9, which is, or square root of 81, which is 9. So 0.7 divided by 9 is your answer.
Well, don't they give us the standard deviation?
Yeah, but not the standard. I know, but not for sample means. They're different. Does that make sense?
Yeah.
I got 0.0 so 3 decimal places. So 0.078.
Wait, what are you doing? Can you explain that equation to me again?
Yeah.
You're taking the standard deviation and dividing it, or?
So yeah, so this one we're finding the standard deviation of the distribution of the sample means.
Okay.
So we just take the standard deviation, which is 0.7,
Okay.
and we divide it by the square root of n, which is 81.
81.
Okay.
So you take 0.7 divided by that, which is 9, and you get 0.078. Did you guys all get that?
Yes.
Yeah.
Okay. What is the probability that the GPA of 81 randomly selected students will be less than 3.3? Okay.
Wait, just really quick. So
Yeah.
we, for number 12, we decided 0.078.
Yeah.
8.
Okay.
Yeah, 0.078. Okay. So for this one, now we have we have 3.3 minus 3.5, and then we do over 0.7 with the square root of 81, but we already know the answer to that one. It's just what we had above. So you just do by 0.078, and then that's your answer. So 0.2, or it should be negative 0.2 divided by 0.078, which is negative,
2.564.
yep, negative 2.564. But we're looking for the
3.5.
Where did I get the 3 point? That's the 3.5 is the mean.
Is the mean given on problem up above?
So the z-score you guys got was negative 2.5641.
Yep.
Okay.
And so now we plug that in. Negative.
Okay, so this equation is the number that they give us minus the mean divided by the z-score.
Not divided by the z-score. We're finding the z-score. It's divided by the sample distribution standard deviation. But usually you would have to do the standard deviation divided by the sample number square rooted. But since we already did that above, we already know it's 0.078.
Okay, that makes sense. Okay.
Okay, and we're finding the probability that is it below 0.3?
So
Yeah. So 0.005
it is.
is what I got.
Are we and we're rounding to the nearest third decimal? Okay, so let's see. Let me double.
0.005.
That's what I got.
Yep.
Okay, number 14. What is the probability that the mean GPA for 81 randomly selected students will be greater? Okay, so the opposite. See, I always get so nervous about these questions, guys, because I mean, if we get one question wrong, we got them all wrong. So, we got 0.995. Is that what you guys got?
Yep.
You're just
That's
selecting
one
the other
minus.
side of the blue thing, right?
Yeah.
Yes,
Yeah, 'cause
1 minus.
Same.
It's the other half. So we have what's below is 0.005, and then just add, or it's just a negative 1 kind of thing. So it adds up to 1.
Okay.
Nailed it. Is this a new question? Oh man, I was hoping we'd be able to be done with it. Okay. The United States Coast Guard assumes the mean weight for passengers in the boat is 185 pounds. 185 is the mean. Previous value was lower, but was raised after a tragic boating incident. The standard deviation of passenger weight is 26.7.
Mhm.
Okay. The weight of a random sample of 48 commercial boat passengers were recorded. The sample mean determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme.
More.
Okay, this one's easy. So we find the z-score for 0.776, and then we do everything below. Yep.
0.776.
1776.
177.6. That's what I meant.
So it's
Okay.
one. Okay. So make sure I'm doing this right. So we're gonna take 1776, subtract it from the one.
Minus 185.
Sorry. Yeah, 185 over 26.7.
6.7.
The square root of that.
And then the square root of 48.
Divided by the square root of 48.
Yes, divided by the square root of 48. You got it. Divided by n. N is the number of
Wait.
samples.
Explain it to me again. So we take 177.6
Minus.
and we're subtracting it from 185, and then
divided by the standard deviation. Divided, which is
26.7.
yeah, exactly. Divide, and then you take so standard deviation, and then divide, and then also divided by square root of
the
n
knowledge.
of number of samples, which is 48 in this case.
so that whole thing divided by the square root of 48, right?
No, just 26.7. 26.7 and the square root of 48 should be in parentheses. You do that first.
Okay. So we're finding the hyphenated,
Finding the z-score, and then we're going to plug it into the applet, and we're going to do everything below.
so confused.
All right, sample mean was determined.
Okay. So that's what the equation looks like.
Hold on, I'm not
Yes.
looking at the camera. So this last question, I'm trying to figure out which side we highlight, because I feel like there's a little bit of a trick there.
Since the answer is negative, coming up with a negative equation answer, I think should be just plug it in and see where it goes.
Yeah, but we got to highlight one area, because it's not asking the z-score, it's asking the probability.
It'd be more extreme, so we're exciting if they're doing the right side.
Oh, hold on. It says, it gives in the note. It says, okay, as extreme or more extreme means that we are not only interested in the values that are lower, but the values that are far away from the mean. Okay, so we're doing the far left and far right. That's what it looks like. Okay, yeah. Okay, sorry, just give me a sec. I got sidetracked there.
Ah,
So did everybody get a z-score of 1.92?
I haven't done it yet. Give me one sec.
figure it out.
So yeah, Michaela, I wrote, I'm sharing my screen, and that's the equation of what it is to get the z-score.
Okay, hold on. I'm not looking at the camera.
It's kind of hard to see it.
Okay, so I did it right.
Yeah.
Okay, thank you. I just, I told you, I don't know. I just must be stupid when it comes to these lessons this week, because I just, for the life of me, could not figure it out.
All right. Ed, did you say you got negative 1.921?
2. Yes.
Okay, so round that up to 9.1. I'm just going to say 9.1215. Okay, then plug that into the applet. So you guys said negative 1.921, and I'm getting an answer of, so we're going for the extreme. So we're going the extreme below or the extreme above, and I'm getting 0.0547.
I agree. I got 0.0549, but close.
Okay,
About
okay, we're rounding here.
around the, yeah.
Okay.
So 1.921 gives me 0.0547.
Okay, either way, I think we're just going to the third number, right?
Mm-hmm.
Yeah, so we're just rounding to the third number anyway, so it doesn't matter. Because either way, it's going to be 0.055. Do you agree, Ed? Does that make sense?
Yes.
Okay, good.
So it's going to be the right of 1.9201.
Yeah, so it's the far left, it's the far right and the far left highlighted because it's worded weird. I don't like how it's worded, but because that note is there, I'm assuming that we're highlighting both because it says find the probability that the sample of passengers will have a weight that is as extreme or more extreme. So either above or below the mean. Yeah, either above or below the mean. Random sample, and and then the note says as extreme or more extreme means that they are not only interested in values that are lower than the ones we observed, but also that are far away from the mean, as ours in the positive direction.
Mm-hmm.
I think we're right on that one. Do you guys want to? I would like to go over all the questions real quick to make sure we all have the same answers. Is that okay?
Wait.
Fine.
So you guys got for the last one 0.055?
Yeah.
0.055, yes.
Yes, sir. Let me double check. Yeah. 0.055. I accidentally had 0.005, so good thing you saved me there, Seth.
Oh.
Alrighty. Let's go from the top or from number 3.
3.
I got 0.175.
Yeah.
All right, number 4, I got distribution of sample means X bar.
Correct.
Right.
Number 5, I got the law of large numbers.
Yep.
Yep.
All right, number 6, I got 1.045.
Uh-huh.
Yeah.
Number 7, I got 0.148.
Yep.
Mm-hmm.
Number 8, I got 2.338.
Yep.
Agree.
Number 9, I got 0.0097.
Yep.
Mm-hmm.
Number 10, I got approximately normal.
Yep.
Yep.
Number 11, I got 3.5.
Yep.
Mm-hmm.
3.5. Uh-huh.
Number 12, I got 0.078.
Mm-hmm.
Yes.
Number 13, I got 0.005.
Mm-hmm.
Yes.
Number 14, I got 0.995.
Mm-hmm.
And then 0.055.
Correct.
All right, here goes nothing, guys.
Submitting.
Come on.
Submitting.
Oh yeah.
17.
How do we do, guys?
100.
Hey, man, we are doing really good. I don't want to jinx it, so let's just say, hey, good job, everybody. So,
Knock on wood really quick. Knock on wood.
Thanks, guys.
okay, that's awesome. Great job, everybody. Good collaboration. I'm good to go. Good work, everybody. We'll see you next week. I'll post this sometime tomorrow. Or on the,
Wait.
All right, then.
what's that? Do you have a question?
No, good, thanks. Have a good night, guys.
Have a good one.